Alrighty, folks, so we're going to do some review here with some stock system, okay, and then we're going to move on to some formula weight and percent composition. So the reason why we even have stock system is because the charges of transition metals can change. So remember, if we're looking at a periodic table, if I ask you guys about magnesium, you know the charge is +2 because it's in group 2. If I ask you about aluminum, across the way here, we know it's +3. And there's no exceptions to that. Aluminum will always be a +3 charge when it's stable. But what about all these folks in the middle here? Okay, what happens to all these transition metals? Well, that is why we have stock system, because the charges of transition metals can change. So for example, iron right here in the middle, iron can be a +2, it can be a +3, it can even be a +6 if it's feeling really saucy sometimes. So that's where stock system comes into play, is because things can change on us with the transition metals. So let's go ahead, let's take a look at this first problem here. We have Zn3PO42. So we got some zinc here. Now the moment you see a formula with a transition metal, you know that if you're going to write that name down, you're going to have to figure out its charge, okay? Well, we don't know what zinc's charge is, but we can kind of look at who he's bonding with here. So PO4, what's PO4? Well, that's two different elements, so I'm not going to find it here on my periodic table because there's no element capital P and capital O, that's phosphorus and oxygen. They're two different places. So what we're going to need to do is we're going to need to go over here and look at our polyatomic ion sheet. This is your blue sheet you guys all have. I'm going to find PO4. Boom, here it is. That is a phosphate with a charge of -3. So I'm coming back over here. It shows me that every phosphate has a charge of -3, and I have two of those guys. Okay, so it gives me a charge of -6 over here. We know that everything has to add up to 0, so we must have had +6 from our metal, our zinc. So the total charge from all those zincs is +6. That means, since there are 3 of them, that each one must be a +2. So you got a +2, a +2, and a +2. Okay? Now, with our visual representation, since we're just drawing out everybody that came to play in terms of ions, we're just going to make sure that we write the charges next to all of them. So we have 3 zincs, all the +2 charge, and we have a couple of phosphates with that -3 charge. The charge of our metal ion is a +2. And just as a friendly reminder, you only need to write +2 if this were your quiz, okay? But just to remind you, that's Roman numeral 2, okay? Just to kind of remind you there. But the only thing you actually have to write down for an answer would just be this +2 right there. And so lastly, what are we going to call this guy? Well, we're going to call it zinc. We can't just say zinc because zinc's charge can change all the time. Which zinc are we talking about? We're talking about the +2 version, and then phosphate. Now, we could also be going on the other way of the street here, where we start with the name and we work our way backwards to the formula. So we have manganese IV sulfite. That's kind of weird. What does the IV stand for? That is your Roman numeral, okay, for 4. Okie dokie. So that is a charge of +4. So again, I'm going to write that here. Now, the Roman numeral IV is 4. I'm just reminding you again, the only thing you need to write in this box is that right there. But now I need to figure out how many manganese and how many sulfites came to play. Well, what is a sulfite, Mr. Pilcher? So some people are going to be tempted to be like, oh, okay, you must just be talking about S right here. That would be sulfide with a D-E at the end, D as in dog. Okay, remember we chop off the end and put ives with our anions in the periodic table. But this is ite, I-T-E, okay? T as in telephone, all right? So we are actually looking at something on that blue polyatomic ion sheet. I'm going to find sulfite here. Here we go. Sulfite, SO3, with a -2 charge. So when I come back to this sheet, I'm going to start by just drawing one of each of these. So I've got a manganese with a +4 charge and a sulfite, SO3, not SO4. It's not sulfate. I'm talking about sulfite, the -2 charge. That does not add up to 0 yet. It's a little too positive, so I'm going to hit it with some negative. Okay, and now that does actually add up to 0, so we're good to go. So we're coming over here. We're going to go ahead and write our new formula. Okay, we have MnSO3 and we need 2 of those guys. I'm like, whoa, 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 Mr. Pilcher, you don't mean SO32, you mean SO3, 2. You need 2 of those SO3s, and so you need those parentheses there to indicate that, okay? So you guys can try the rest of this worksheet here. The answer key is below this video, okay, if you need it. But make sure you can go from the formula to the name, but also the name to the formula, as well as be able to provide these visuals up here for me, indicated in this column here. Now let's talk about some formula weight and some percent composition, okay? Formula weight, percent composition. We're going to do a problem or 2 on the front, and then we're going to try one on the back, and then we're going to be good to go. So the first one we're going to try here is this guy, NH42SO4. So the very first thing we're going to do is we're going to write down every element that is in this formula. Now, I'm going to go ahead and clear out these other guys to give myself some room to work. And please notice how meticulously organized I'm going to be. I'm going to really write everything out. That way I'm going to prevent mistakes. And also, when I check my work at the end, it'll be easy to find a mistake if I've accidentally made one. All right, so I'm going to list out all the elements I see. I see some nitrogen. I see some hydrogen, some sulfur, and some oxygen. Now, before I go any further and I try and count these guys, I'm going to draw out, just provide myself with the visual for this ammonium sulfate just to make sure I know what I'm looking at. Now, you don't have to draw this out, but some people feel like it helps early on. So we have an NH4 with a +1 charge, and there's actually 2 of those guys, okay? That tells us that there are 2 NH4s with that +1 charge. You just got that one sulfate with a -2 charge, just like that, okay? So, uh-oh, raised too much, there we go. So that's what we're dealing with. Now, when you go to count your nitrogens, because what I want to do with these elements and want to count how many I have of each one, you can see that there's nitrogen here and here, so we got 2 of those guys. But you could, if you didn't ever draw this out, you could just see, hey, I have 2 ammoniums. There's 1 nitrogen in each one, so 2 times that 1 gives me 2. How many hydrogens? Well, I have 8. Okay, I got 4 in each ammonium. I've got the 1 sulfur, and I've got 4 oxygens. Now what I'm going to do is I'm going to multiply each one of these by their formula weight given on the periodic table for these individual elements. So I'm going to find nitrogen, hydrogen, sulfur, and oxygen. Nitrogen has got a formula weight of 14. Oops, I want to go ahead and do this. Nitrogen's got a formula weight of 14 right here. We're just going to round to the closest whole number. Oxygen's right next to it. I know oxygen says 15.99 something, but we're just going to call that an even 16. Sulfur's over here, it's got a 32. And hydrogen's just a good old number 1. Okay. Now you will probably memorize some of these as time goes on, but you never have to. You'll always have these masses provided to you when you need them. Okay, on any quiz or test. All right. So I'm going to multiply each one of these by their individual masses. So nitrogen we just saw is a 14. So it gives us 28 from the nitrogens. Hydrogen's a 1. Gives us another 8. Sulfur is a 32. And oxygen's a 16. And there we go. Now, what am I going to do with all these? I'm going to add them all up to get that grand total. And I'm going to find this comes out to be, let's see here, 132. So my formula weight equals 132, and that's what I'm going to box up as the model student. There aren't any units for formula weight, so I'll just put FW, standing for formula weight, equals whatever your number is, and box it up. So that's probably the toughest problem on the front. That one, or maybe this guy right here, the calcium phosphate. If you're a little confused on that one, maybe give this guy a shot down here in the bottom left before moving on. But you should be able to calculate those formula weights, and we're going to use these constantly in Unit 6 and 7. So we're going to be using these all the way to April, probably. Now, so the first questions on the quiz, they just ask formula weight, and that's all I ask for. You can stop right here. But sometimes I'll ask you a slightly different question. I'll ask you about the percent composition of each of the following elements, okay? So I want to know, hey, what percent of this formula is calcium, what percent is fluorine, that kind of thing. And so you're going to have to look at the individual contributions of each element percentage-wise. Now these problems, they start the exact same way. You're going to have to find the formula weight no matter what you do. We're going to go ahead and take a look at this guy right here, H2SO3. I'm going to start just like I did last problem. I'm going to list all my elements, H, S, and O. I have 2 H's, I've got 1 S, and I've got 3 O's. Now the mass of any given H is 1, okay? Again, I'm getting that number from this periodic table, okay? This guy right there. And then oxygen was 16 from last problem, and sulfur was 32. So I'm going to use those numbers here. Boom. So I've got the 1 sulfur times its mass of 32. I've got the 3 oxygen times the mass of 16. When I add all of these up, I'm going to find that my formula weight comes out to be 82. Now, if I asked you for the formula weight, that's all you would need to do. That would be your final answer. But on this problem, I'm asking you for percent composition. So what we're going to do is this 82 becomes our denominator for these different contributions from the various elements. And I want to find out what percent of this 82 comes from hydrogen, what percent of this 82 comes from sulfur, and what percent of this 82, this formula weight, comes from oxygen. So I'm going to divide each one of these guys by 82. And this will give me some sort of decimal, okay? Be less than 1, it'll be a kind of small number. And then to kind of clean them up and make them a nice clean percent, I'm going to just go ahead and multiply each of those by 100%, just like this. Okay? So now, I'm going to go ahead and just plug this into my calculator. So when I plug in 82, or 2 divided by 82, and I multiply that, I'm sorry, 2 divided by 82 comes out to be 0.024. And when I multiply that by 100%, it tells me I have 2.4% hydrogen. Okay? 32 divided by 82 comes out to be 0.39. And when I multiply that by my 100, I get 39%. And call it 0.0, I guess, just to be consistent here. You can just do 1 decimal in these. You don't have to worry too much about the rounding. Just be consistent. So I got my 39.0% sulfur. And then lastly, I'm going to come out to have 58.5% oxygen. One way you can kind of check yourself is that all of these numbers should add up. I'm going to box them up since this is my final answer. Notice I have each percentage labeled with an element symbol. So I know the 39.0% is for sulfur, not hydrogen or oxygen. Now all these should add up to about 100%. You'll see that my numbers here add up to 99.9%. That's okay. That's probably just a rounding thing. That's basically 100. So if you get 99.9 or 100.1% total, that's okay. But if you were to add these up and they came out to be like 72%, you'd be like, whoa, 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 that's a red flag. Something has gone wrong. Okay, so you're going to want to look into that. So feel free to knock out the rest of these problems. You can especially go for some of the saucier ones, like this guy right here is pretty tricky. So go ahead and give those a shot. Your quiz will go over not only just a regular old formula weight, which is what we did on the front with this guy, but you also need to do a percent composition, which requires you to do a formula weight, and then to go ahead and find the percentage contributions of each element like we did here. Okay, please let me know if you have any questions. I will see you nerds next time.